This is Project 21 from the Arduino Project Handbook, Volume 1 by Mark Geddes. You can use this alarm to trigger a variety of outputs such as lights, motors, or even a welcome home message when you approach your front door. Let me show you how it works. When this project is successfully built, the sensor will detect motion and trigger an alarm buzzer and an LED light to light up. We're building it on a Workbench project development kit from PhaseDoc. You can learn more about the Workbench PDK at phasedoc.com. An Arduino controls the project. We used a breadboard to mount the LED and the buzzer. In addition, the project uses a passive infrared motion detecting sensor. We'll call it a PIR from here on out. So when you plug it in, bring power to the battery, and plugging the power cable into the Arduino and turning on the battery. The alert sounds, and it takes about 30 seconds to reset. And there you have it. The first thing you need to do is to mount your breadboard and your Arduino onto the Workbench base. Start with the Arduino in the center with the sensor pins closest to the breadboard. That'll make it easiest to wire up. Then if you are using a battery, you can mount the battery on the opposite side. In step 2, you upload the sketch program to the Arduino. See the Arduino Project Handbook for the details. In step 3, wire the power and the ground between the Arduino and the breadboard. Use the Project Handbook to make sure you get them in the right pin. And if you're not sure how to use the breadboard, there's a really nice description on pages 4 and 5 of the Project Handbook. Wire the LED through the breadboard. Although this project doesn't call for it, it's a best practice to place a resistor in line with the LED, so we added one here. We recommend something in the range of 2,000 to 5,000 ohms, depending on your LED. Although the Arduino Project Handbook shows the buzzer as a separate unit, we installed the buzzer into the breadboard. This offers a secure way to mount the buzzer onto the Workbench. We also used the 3-prong buzzer from the 37 sensors kit instead of the one shown in the Arduino Project Handbook. The 6th step is mounting the PIR sensor. Following the diagram in the Project Handbook, we recommend inserting the power, ground, and signal wires into the sensor before you run them to the Arduino and to the breadboard. We found the PIR sensor a bit challenging to mount. It's got these components that stick out on the bottom, so there's no natural way to screw it down or attach it to the breadboard or the base. It has some mounting screws, but there's no way to use them with all of the components on the bottom. So given that this is a prototype, the easiest way to do it, and I wouldn't recommend using this approach for anything but a prototype, but we actually used a little rubber band, which we brought in and put over the legs of the click and around the breadboard. So I'm going to reattach that to the base. Now the tricky thing, and really it's easier if you actually could put the rubber band in before you started running any of your wires. Tuck the PIR sensor under there and rubber band it. That way it faces out and it's a little easier to interpret. For a more permanent mounting solution, we really advise that you consider 3D printing an adapter. Now let's plug in the power and check it out. Power cable to the battery, and here's your power to the Arduino, and we turn on the battery. The manufacturer claims the PIR sensor will trigger from as far away as 7 meters, but we really only tested it up to 2 to 3 meters. After the alarm sound, it takes a few seconds, about 30, to reset, but you can modify the code if you wish. Congratulations, you have a working motion sensor alarm. So unplug that baby, grab your cover, and slide it right into your backpack and show it to your friends.